Today, tomorrow's going to be worse.
I wish it was on Tuesday.
You wish it were on Tuesday?
Yeah.
Would you like to be disrupted on Tuesday?
No, I thought I could stay home and watch.
Oh, there's nothing to do. It won't disrupt anything, is what you're saying. What about this class? We have this class on Tuesday.
No, that's what I mean. But you would just like.
Oh, stream it. Yeah, yeah.
But I can't stream quiz.
You can't stream a quiz. No. Yeah. Okay. I see your point. So we are going to keep working. We did law of sines yesterday, and that allows us to solve some kinds of oblique triangles, certain cases. And we're going to do law of cosines, which will take care of the other cases. An oblique triangle, remember, is just one without a right angle, so we can't use SOHCAHTOA or Pythagoras. We're going to have a quiz today, so as we usually do, we'll just jump right into the new stuff, and then we'll do questions on quiz material right before the quiz. Feeling good? Extra good? Not good, extra good. I get it. Oh. Okay. So the law of sines came as like proportions that are equal to each other, just basically saying that if you take a proportion of a side to sine of the opposite angle, that's constant. So A over sine A is B over sine B is equal to C over sine C. The law of cosines comes as a set of three equations, but really it's like one template equation, and then you get the different versions of it based on which angle your focus is on. If you look, especially if you look at the bottom one, it seems reminiscent of Pythagoras, right? It's sort of almost Pythagoras, except we have this extra term on the end. Pythagoras is like a special case of the law of cosines when you have a right angle. So essentially, all of these come in the form of note that whatever side we're squaring on this side corresponds to the angle, the opposite angle that's inside the cosine function. All right, so b squared cosine b, c squared cosine c. And then the other side of the equation involves the other sides of the triangle. So the first equation, we have a squared, right? So there's our a side. The other side only uses sides b and c. So b squared plus c squared, and then minus 2bc cosine a. You don't have to memorize this equation, but what I do is I give you one version of it, and then you have to be able to reproduce it, make an adjustment if you're trying to get it for the other angles. Okay. So law of cosines is most helpful in case 3 and 4. So remember, with an oblique triangle, we can solve it if we have 3 pieces of information, at least one of which has to be a side. With the law of sines, we always need to make sure we had at least a matched pair, like a side and the angle opposite that side. We don't need that necessarily anymore. We can solve a triangle if we know 2 sides and the included angle. So maybe this side is fixed, that side's fixed, and I know that angle. So that obviously will fix that side. If this side length is fixed and that side length is fixed and the angle is sort of welded at that measurement, that'll fix the other side. We can use law of cosines to solve that. And then in the last case, if I just know all 3 sides and know angles, we can use law of cosines for that. We spent a bit of time on Tuesday talking about the ambiguous case, talking about, the shortcoming of the arcsine function is that it's only ever going to give you an acute angle. So in a situation where maybe there's a couple triangles that we could solve, when we use law of sines to solve that, it'll only give us the acute solution for that other angle. And we have to be kind of clever and make adjustments if what we're looking for is the obtuse angle. The arc cosine function doesn't have that shortcoming. Arc cosine will always deliver an angle that's between 0 and 180. So if you're using arc cosine to solve for an angle, you're going to find whatever angle it is. There's no it could be this or it could be that. There's no ambiguity there at all. We're going to know what that angle is. When we know all 3 sides, then everything we're going to do is find the angles, right? So law of cosines can be used where law of sines can't in that situation because I don't have a matched side angle pair yet if I just know all the sides. If we make sure that we find the biggest angle first, then we know the other two angles will be acute, and that's helpful because if I don't want to use law of cosines again, I can use law of sines and I know I'll get the correct angle. Law of sines will only return an acute angle. We're going to do some examples. So here we have two sides and the included angle. And we just want to solve this triangle. So we want to find side B, angle A, and angle C. If we start by finding side B, and we can do that. Let's see what law of cosines tells us. If I want to use law of cosines to find side B, I'm going to use the version of law of cosines that begins B squared by itself. That's really how law of cosines is most useful for finding sides. So B squared equals, and then A squared plus C squared minus 2AC cosine of B. Note that I know angle B, I know sides A and C. So like I have everything that I need to plug in on this side. I'm just going to find B squared, take a square root. And then we just want to be careful about how we're plugging everything in. Square root 0.1672 squared plus 0.5143 squared minus 2 times 0.1672 times 0.5143 times cosine 128.3. 0.6317. I'm using the same number of significant digits. I'm just, I guess, kind of assuming these might have come from measurements or something, or maybe they're approximate numbers. How's that? Some people find law of cosines a little bit cumbersome to work with. Like, it's not that hard, but there's a lot more stuff to punch in the calculator, maybe more opportunities for errors. So we'll just, I want to point out that now we know this side, 0.6317. And now the position that we're in is that we have a matched pair. We have a side and the angle opposite that side, which means we're now in the territory where we can use law of sines. So you could also, you could also use law of cosines to find the other angles. But here's what I want to point out, and sometimes we might want to do that. Sometimes we legit might want to do that, but we'll note that the angle they gave us is an obtuse angle. I know those other angles are acute, so that if I use law of sines to find an angle, the arcsine is going to give me the angle I want. So let's say we find angle A, then we're going to use A over sine A equals B over sine B. I'm going to use the given matched pair, or the the match pair that we now have that after we found B. I'm actually, before I plug stuff in, just because I find it convenient, gonna just manipulate this as a formula first, and then I'll throw in the values. So we get B sine, if we do the cross product, B times sine A is equal to A times sine B. And so sine A is A times sine B over B, and so A is arcsine. Arcsine of 0.1672 times sine of 128.3 over B, which is 0.6317. .99 degrees, or if I'm going to the nearest tenth, 12.0 degrees. So now we have B. We found side B before, now we have angle A. The only thing left to do is to find angle C. And that's the easiest part now. Just going to subtract from 180. $39.7. How's that? Not bad. Okay. We do have one built-in check, not like an accuracy check, but a does this make sense check. And we just always remember that the longest side is opposite the biggest angle, and that did in fact that was the case in this triangle. Questions before we do another one? Okay. So case 4, suppose I know all the sides and I know none of the angles. We have to start out by picking an angle to solve for. Arc cosine will always give you the correct angle that you're looking for, right? There's no shortcoming. It can give you an obtuse angle. And so I want to first, if there is an obtuse angle, I want to find it. I want to find that one first, because then I will be in a position to be able to use law of sines if I prefer that to law of cosines. I can use law of cosines for all three of them. That's fine. It ends up being, it's a little cumbersome, like plugging all that stuff in the calculator. People like law of sines because it's usually simpler to manipulate. So if I want to minimize my use of law of cosines to make it easier, the calculation part easier, I'm just going to pick what I know has to be the biggest angle and solve for that first. Which angle should I find? A. It's opposite the longest side. So we're going to find angle A first. And the equation, the law of cosines equation that uses angle A is the one that begins with side A squared. So I'm going to use the equation A squared equals B squared plus C squared minus 2BC cosine of A. And before some people like to just plug stuff in right off. I'm going to manipulate this first and solve for angle A as a formula, and then have something I can plug my sides into. So I'm going to add 2BC cosine A. I'm going to isolate this term first, and I'm going to subtract a squared. So then we get 2bc cosine a equals b squared plus c squared minus a squared, and then we'll divide by 2bc. So cosine of a is b squared plus c squared minus a squared over 2bc, and that means that, let me come over here, it means that a is arc cosine of that fraction. We got to be really careful when we plug this stuff in the calculator. Be careful with your parentheses. So if we plug in the values, b squared, so 22.62 squared plus c squared, 42.27 squared, minus a squared, 51.43 squared, all over 2 times 2262 times 4227. When I plug this in the calculator, I'm going to be really careful and make sure that I have a set of parentheses around the numerator that goes inside the arc cosine and a whole set of parentheses around the denominator. That's super important. You will not get the correct result if you don't have if you don't encase your numerator and denominator separately. Alternatively, some people will just figure out what this is, what this fraction is, plug in the sides and stuff, so we know what cosine A is equal to as a number. If you do that, just don't round too coarsely. You also would still need to make sure you have parentheses around the top and the bottom separately in order for your calculator to do what you're trying to get it to do. So we have arc cosine. And then, so it automatically opens parentheses. I'm opening another set of parentheses for the numerator, 2262 squared plus 4227 squared minus 5143 squared. Closing the numerator parentheses, divide by opening parentheses for the bottom, 2 times 22.67 times 4227. Closing the parentheses on the denominator, closing the parentheses on the arc cosine. If you make a mistake, it might throw a domain error. Because remember, cosine cannot be bigger than 1 or less than -1. So if you do something like forget parentheses, it's quite possible you'll get a value that's bigger than 1 or less than -1, and then it will throw a domain error. So if that happens, just go back and reevaluate how you're plugging it into the calculator. So we get 100.4 degrees. What can we do now? We want the other two angles. We can use law of sines. You can also use law of cosines again if that was enjoyable and fun and you want to do it. And by the way, nothing wrong with doing it more while we're learning it, right? Like getting used to how it works. But yeah, usually it's easier now that we have that matched pair, and I'm guaranteed the other two angles have to be acute. That just use law of sines. So let's say we find angle B. Then B over sine B. And now the other one that I want to compare it to is A over sine A, because angle A is the one I know. And I'm just going to do the same thing. I'm going to manipulate this so that I get angle B first as a formula, and then I'll plug the stuff in. So A sine B is B sine A. That means that sine B is B sine A over A, or B is arcsine of that. arcsine of B, side B was 2262 times sine of 100.4 degrees over side A, which is 5143. $25.6 degrees. Now we have two angles. So the last angle is not too difficult to get. We're just going to subtract from 180. $54.0 degrees. How's that? Are there questions on that example? Okay. Well, let's try one more. So this is another, I guess, case 3 where we have two sides in the included angle. They tell us that they give us angle C and they give these sides A and B. What can we find first? Like, what's the low-hanging fruit, I guess? Side C. So if we use law of cosines to find side C, that's the equation that goes C squared equals A squared plus B squared minus 2AB cosine of C. We know sides A, B, and angle C. So we have everything that we need to plug in to the right side. So let's start plugging stuff in. Square root of 29.7 squared plus 44.2 squared minus 2 times 29.7 times 44.2 times cosine of 35 degrees. I just got a domain error, so, or non-real answer.
26.2.
Okay, I want to find my error though. Hold on. Everybody's like, just hurry up and do it. 29.7 plus 44.2, 29.7 squared, 44.2 squared, minus 2 times 29.7 times 44.2 times, okay, times cosine. I did that subtract the thing, you know, subtract 2ab cosine c. I did it twice in the radical, which made it negative, so that was a problem. Yeah. 26.2 degrees, or 26.2, it's a side length. 26.2 is a side length. Cool. So look, now we have an angle and a side opposite that angle. And in the first one we did, we said, okay, well now we can use law of sines. And we can use law of sines. We have to be careful, though. In the first example we did, the angle they gave us was obtuse, so we knew the remaining angles had to be acute, and that we could pick whatever angle we wanted to solve for and be assured that the arcsine would give us the angle we want. But right now it looks like it's plausible that that's an obtuse angle. Even if it didn't look exactly obtuse, it's opposite the largest side, and so they gave me an acute angle. I'm not going to solve, if I'm using law of sines, I'm not going to find the biggest angle, because there's a possibility it could be obtuse, and arcsine's not going to give me that angle. So if I want to use law of sines, I'm going to pick angle A, because I know that has to be acute. You know, a triangle can only have one obtuse angle, and it would have to be opposite the longest side. So I'm either going to use, if I want to find angle B first, I can, but I really should use arc cosine. I should use law of cosines. It's easier to use law of sines, so we'll just use law of sines to find angle A. So A over sine A is C over sine C, which means that C times sine A is A times sine C, or sine A over C. A is arcsine. So side A was 29.7 times sine of 35 degrees over 26.2. .6 degrees. And now we know two angles. We'll just find the third angle, subtract from 180. Angle B. .4. So, you know, when you're solving for angles in an oblique triangle, I guess we obviously don't want to make more work for ourselves than we need to have. Like, go ahead and find the most efficient way. If you don't like law, you know, if you prefer law of sines to law of cosines, okay, like we definitely took advantage of the fact that that's kind of easier to work with. You just have to be really cognizant of what kinds of results that the arcsine can give you. You know, make the best decision of, if I want to use law, we have to be really aware and say, okay, if I prefer to use law of sines, great, but that means I really should focus on that angle first. That way, if angle B is obtuse, I'll still find it, right, by subtracting from 180. Questions? So if there aren't questions on this, then I'm just gonna we're gonna finish this chapter on Tuesday. We have like just a couple like application examples that we're gonna do. That's gonna take more time than we really have if we want to do a quiz today. So I'm gonna push finishing this chapter until Tuesday. Which means we'd be in pretty good shape to take the test either Tuesday the 18th or Thursday the 20th. If we take the test on the 18th, then we'll finish material on the 11th. The 13th will be a day to work on the problem set and get questions answered and stuff, and then we'll take the test and we'll start the next chapter on a Tuesday. If we, and actually we might even start the next chapter a little bit on Tuesday the 11th, like, because I don't think it'll take the whole time to do those applications. But if we do the test on the 20th, then we'll finish the chapter on the 11th. We'll be working through starting the next chapter, working on that on the 13th, and Tuesday the 18th we'll use to work on the problem set in class, and we'll take the test on the 20th. So my question to you is, do you have a preference between doing it on the 18th and the 20th, knowing that we're going to be doing some work on the next chapter that won't be on the test if we take the test on the 20th? We have the week of the, if this matters to you, we have the week of the 24th off. There's no classes that week. So who prefers the 20th? Who prefers the 18th? Oh,
50-50.
yeah.
That was
Huh.
that was like 3D.
Way to be on this.
I know.
What about April? Like 3rd.
April? But then we're going to cover a lot more material before we do that test.
When
What?
do we graduate?
I feel like that'll be awful.
What?
Can we just do it graduation day, like on the way up?
I have to go to graduation.
Exactly. You can probably.
Oh, perfect. Okay, I see your point. So it's pretty much even. You know what? I'm gonna let's do.
Only flip a coin.
Do you want to flip a coin?
The teacher's choice.
No.
I, don't do.
Let's do the 18th.
Okay, raise your hands for the 18th.
Just so it works.
And the 20th. Yeah, I guess the 18th has it. Okay. I'll have the problem set ready on next class. That's Tuesday. And it'll probably be posted to Canvas before then.
Is it the same length as last semester?
What's that?
Is it the same length as last
The problem sets? About. Yeah. Okay. So now that that's settled, who has questions about the quiz material? There's some a couple vector problems, a couple of law science problems.
Number 3. Number 3 is one of the
On the practice quiz?
I didn't see solutions to the.
Yeah, you know what? I just finished writing them. Sorry. Actually, I could just bring them up. Hold on. So I'll just go through them one by one a little bit, and so we'll definitely get to 3. So here's an application problem. Here's our force or tension vector of 55 newtons. Tension is a force, I guess. 55 newtons along that rope that's pulling in the boat. And we want what force tends to bring the boat toward the wharf and what force tends to raise the boat. So that is, toward the wharf is what's the x component, what force tends to raise the boat is the y component. What we're missing is the angle. And we could find it because they give us these linear measurements. So, they don't tell us that what the x and y components are, but because they give us these linear measurements, we know what that angle is, and we can use arc sine, right? SOHCAHTOA, sine of theta is 4/12, so we get that angle. And then towards the wharf, there's our 51.8 newtons. And I just use this as an acute angle because, again, in nature, I could just get up and stand on the other side. If you wanted to say that that's really one 60.5 degrees, viewing this as a second quadrant, then you get the same Fy, Fx would be negative, that's fine. You're just indicating the direction. Questions on that one? The second one, we were adding these two vectors. And so the first vector, they give us the magnitude and the direction. There's a nice standard position angle. The second vector, vector W, they don't give us the direction as a standard position angle. They measure it back from the 270. They give us an angle measured from the vertical. So the first thing I do is just find that angle for the standard position angle for W. And then adding the vectors works basically the same way. Find the x and y components for each vector. That's what I did down here. And then you get the x component for your resultant by adding the x components, the y component by adding the y's. X ended up being negative and y was positive, so that means we're in I didn't finish writing that. That means we're in quadrant 2, which makes sense. Like if I think of adding these vectors tip to tail, slide the w so it starts at the end of v, that should end up in quadrant 2. So we use Pythagoras here, and then since we're in quadrant 2, 180 minus the arctan. Now question 3. Now we get to Austin's question. 2 ropes are attached to the top of a crate to raise it. The force in one rope is 240 pounds at 25 degrees from the vertical. So I put that one, I just chose to put that one on this side, but if you put it on this side, that's fine. 25 degrees from the vertical. So drawing it in this first quadrant means that the standard position angle is 65 degrees. So I know what that force vector is. And then we have this other force vector. They don't tell us how much force it is, but I know it's 35 degrees from the vertical in the other direction. It would only make sense for it to be in the other direction, because otherwise the crate isn't just being lifted, it's being moved, like horizontally. So the concept behind this problem is that since it's just being raised, their forces combined ends up just being a vertical force. So like the x component of one force has to cancel out the x component of the other force. We can find the x component of F1 because I know the magnitude and direction. So there's the 101.43 pounds. And because those forces combine to have a net 0 x component, because it's just being raised, it's not being moved, like horizontally, that tells me that the x component for the second force has to be negative 101.43. Does that make sense? So now I know the x component for F2. So here's the formula for the x component. I know the x component, I can plug that in. I know the angle, so I can plug that into cosine. That allows me to use algebra to solve for the magnitude. We divide by cosine of 125 degrees, and we get our force vector is 176.8 pounds at the angle which we had already found to be 125 degrees. Does that help with that? And then there were a couple law of sines problems. So I said use the law of sines to solve for side C. Pay attention to the instructions because you can waste time finding things you don't necessarily need. They just said solve for side C. So I'm not going to bother finding side B. I don't have to. You can if you want to, but like if you don't, if you're worried about time, you don't have to find things that you're not asked to find. We do have to find this thing we weren't asked to find, though, to use law of sines, right? We needed to find angle A to have a matched pair, but that was easy, right? Just subtract from 180. Then we have a matched pair, and we're ready to use law of sines to find side. Side. That's funny. I did find side B, even though I don't need to find it. Just for fun. I think as I was going through this, my mental capacity these days is such that I lose focus on something. So I just pointed out, read the instructions. You don't have to solve the whole thing. And as I was working on it, I was like, gotta solve the whole thing. So I did.
Did you see the solve for side A and then just go for it?
What's that?
Did you just go for the whole triangle?
Yes. Yep. That's what I did. So anyway, that's what I got for that. And then use law of sines to find angle C. And they gave us, so we had to draw our own triangle. They gave us an obtuse angle, so this is not an ambiguous case scenario. I don't have to worry about that. So I just drew, I'm a creature of habit, and whenever I have an obtuse angle, I almost always draw it at the top for some reason. So there's a angle B at the top. They gave us side C and side B, and we wanted to find angle C. So they gave us a matched pair, which means we're ready to use law of sines if we want to, and we should because we're asked to do that. And then we use arcsine to find angle C. How's that? Questions? Okay.